This is the Mechanics Homework Booklet, question 23. The diagram shows the flight of a cricket ball when hit by a batsman at 30 degrees to the horizontal at a speed of 22 metres per second. The ball reached a fielder without bouncing and was caught at the same height as it was hit. We're also told that we can ignore any effect of air resistance. First of all, you are asked to calculate the vertical speed of the ball at the instant it left the bat. That means you need to resolve this velocity vector into the vertical direction to find the vertical component here. You could, if necessary, sketch a triangle at this point to help you with your trig function. Looking at the diagram, I can see that the vertical component is going to be 22 sine 30. You could express this as 22 cos 60 if you prefer. That leads us to an answer of 11 metres per second. Next, you are asked to show that the ball was in the air for about 2.2 seconds. Very important that you respond to the show that command. This means that all steps must be visible, and it's very likely that there will be a method mark in the mark scheme. This can lead people to lose marks because if they don't show their working clearly, even a correct answer may score nothing. So, explaining that we are considering the vertical motion to the maximum height, we don't know the distance to that height, but we have just worked out the vertical component of the initial velocity. That was 22 sine 30 or 11 metres per second. If the ball travels to its maximum height, the final vertical velocity will be 0. And if we consider upwards as positive, as we have done by stating u as positive, then the acceleration must be in the opposite direction and be shown as negative. Since we don't know s, we want an equation not using that variable, so v equals u plus at works well here. Because it's a show that question, I've chosen to do the rearranging first and then the substitution, leading to an answer of 1.12 seconds. This is the time taken for the ball to reach the maximum height. However, we are asked for the time that the ball is in the air. This will be double that time, so the ball is going to travel upwards and down again, and we double our answer for time here. This gives us an answer consistent with what was given in the question. If you prefer, you can solve this question by saying that considering the whole journey in one go, the displacement would be 0. The initial velocity would be the same, and the final velocity would actually just be the opposite of the initial one. That would lead you to the same answer, and you would then find the full value of t and not be doubling. Finally, you're asked how far the ball travelled horizontally before it was caught. So here we need to consider horizontal motion, and you can find the horizontal component of the velocity as 22 cos 30. This horizontal velocity must then be multiplied by the time of flight, leading to a final answer of 42.7 metres.